have found a planet around the nearest star, Proxima Centauri. So this discovery didn't happen obviously from one day.
So what's the closest Earth-like planet you think is worth visiting? How hard is it?
Proxima Centauri. It's over 4 light years away.
Beyond our expansive cosmic neighborhood, billions of kilometers distant from the activity of our planet, is a mysterious world known as K218b. A huge find shines in the pitch-black emptiness of space. Carbon-bearing compounds, namely carbon dioxide and methane, have been found on this far-off exoplanet for the first time. The James Webb Space Telescope's unmatched vision made this astounding discovery, not just any telescope. Now, why should you care about this, and why does it matter? Take a moment to dive deep with me. The first thing that comes to mind when we hear words like carbon dioxide or methane is our own planet, with its huge marshes producing bubbles of CO2 or methane that we have all grown all too acquainted with from conversations about climate change. However, locating these identical molecules on a distant planet, the plot becomes more complex at that point. Let's frame our story first. A galaxy full of planets, stars, and unsolvable puzzles serves as the stage. Here comes K218b, a massive exoplanet that is 8.6 times as massive as Earth. To put that into perspective, it would be like stacking Earth nearly 9 times over on top of itself. It may be a Hycean planet, but this isn't just any exoplanet. A world with the potential for a hydrogen-rich atmosphere and perhaps even an ocean surface is known as a Hycean planet. Yes, you read correctly. Oceans that resemble Earth but also have a hint of cosmic mystery. Astronomers are searching for hints in the expanse of the cosmos, not only stargazing. Some clues that could help us answer some of our hardest questions. Are we alone? Are there additional planets that could support life? To what extent may these livable settings be varied? For space lovers, this new discovery is more than simply a trivia fact. With its abundance of these carbon-containing compounds, the atmosphere of K218b suggests a universe that is unlike any other. It whispers stories of other skies, and perhaps, just possibly, the secrets of life on other planets. The discovery is all the more intriguing because K218b is located in the habitable zone, a sweet area orbiting its star where circumstances may be ideal for life. Perched tantalizingly in the Leo constellation, the Sub-Neptune world K218b is a puzzle. It is a unique player in the cosmic arena due to its size, which dwarfs our planet but is little in comparison to Neptune. These enigmatic sub-Neptunes, which have no analogs in our own solar system, continue to be a mystery to astronomers. Don't believe it if you think this sounds like science fiction. We are being challenged by the universe, which taunts us with riddles and mysteries. We are getting closer to the most important realization of our time, that we are not alone, with each molecule found here and each light shade examined. The cosmos never stops surprising us, and the saga of K218b gets more complex as our story progresses. This world doesn't only orbit in a far distant part of the galaxy. Rather, it is carefully arranged in a celestial dance around its parent star, K218, a cold dwarf star that provides our mysterious exoplanet with a glowing background. Just picture the majesty of it all. This spectacle occurs in the constellation Leo, the powerful lion of the zodiac, 120 light-years away from us. Isn't that almost poetic? Let's now focus on the parent star's significance and how it interacts with the exoplanet. Space's complexities tell a story about atmospheres, possible life, and limitless possibilities in addition to distance and orbits. In the immensity of space, worlds like K218b, which alternate between the sizes of Earth and Neptune, are unique gems. They are an astronautic mystery due to their inherent distinctiveness. They are unlike anything else in our solar system. Sub-Neptunes, a sort of middle child in the cosmic family, are not just any planets. Are you ever left wondering what is beyond our recognizable skies? Consider it. This is a world that is neither Earth nor Neptune, and it raises issues that we had not even thought about. What mysteries lie within its atmosphere? What secrets lie behind its ostensibly aqueous exterior? Astronomers continue their discussion, with each new discovery being more fascinating than the one before it. The idea of a Hycean exoplanet gives this story a particularly intriguing twist. It's more than just a fancy name. It's a doorway to the universe's many and ever-changing potential living conditions. The bigger Hycean worlds provide fresh opportunities, even though we have spent years studying rocky planets that are relatively similar to our own. They entice us by hinting about possible habitats and atmospheric delights. This is clarified by Niku Madhusudan, an astronomer at the University of Cambridge, who highlights that our hunt for extraterrestrial life has possibly been a little limited. Because that's where the light is, it's like searching for keys beneath the same street lamp. However, what if the keys are out there, in the shadows, just waiting to be discovered? Madhusudan's observations encourage us to broaden our perspective, investigate unexplored areas, and satisfy our curiosity. Do you not want to know? Could our quest for life be reframed with the advent of the Hycean worlds? Could the immensity of space be teeming with life, concealed in unexpected places? Methane, carbon dioxide, and possibly even traces of a chemical with significant ramifications, dimethyl sulfide, DMS, are shown by K218b. These molecules' existence is more than a mere atmospheric fact. It's a hint, a pointer to something much more significant. The cosmos seems to have left us a path of discovery in the form of breadcrumbs. Why, one might wonder, is there such a stir over the mention of DMS? Despite its seeming harmlessness, this molecule is extremely important to us on Earth. It's not a haphazard chemical. DMS is essentially a life signature. Life indeed. Phytoplankton from maritime habitats is the primary source of this chemical on our home planet. These microscopic organisms beneath the ocean surface are therefore creating a chemical that may serve as a beacon of life somewhere in the cosmos every time you stand on a beach and gaze out into the huge ocean. We shouldn't get ahead of ourselves, though. Although the concept is intriguing, the proof isn't yet conclusive. As Madhusudan correctly notes, more research is crucial. Although encouraging, these preliminary findings need to be confirmed. What would be the next course of action? The excitement as researchers go further into K218b's atmosphere in an effort to find unmistakable proof of DMS? The ramifications might be enormous. What if life as we know it existed on this far-off planet? Or maybe life as it isn't known to us? It is crucial to keep in mind that life is not synonymous with the presence of carbon-bearing molecules or even DMS when we reflect on these discoveries. K218b is a mystery encased in layers of high-pressure ice, surrounded by an atmosphere full of hydrogen and possibly topped with an ocean surface. Oceans of water could exist on these Hycean worlds, but there's a catch. The water may be extremely hot, perhaps too hot for any life to survive or even stay liquid. These subtleties are what give the K218b narrative its fascinating quality. Every new finding reveals layers of complexity, much like when you peel an onion. We are exploring the fundamentals of what makes a planet habitable, not just gases and chemicals. Even though we have discovered intriguing hints regarding the possibilities of this exoplanet, it is important to approach such discoveries with a healthy dose of both enthusiasm and caution. Because K218b does not automatically qualify as life-bearing just because it is located in the Goldilocks zone, which is the area surrounding a star where circumstances may be ideal for liquid water. Imagine a planet in the best possible location where the warmth of its star might cause aqueous oceans to shimmer beneath alien suns. Doesn't the mere concept chill you to the bone? But here's a twist. What if those seas were as hot as cauldrons in fantastical stories? What if the conditions on K218b were too severe for life as we know it, even though it was in the so-called habitable zone? Let's take a moment to analyze that. The word habitable has been ingrained in our language and frequently conjures up visions of paradises like to Earth. However, habitable is a complicated, multidimensional phrase in the vast cosmic fabric. Earth 2.0 isn't necessarily implied by it. It might point to a world in which there is liquid water, but it is tainted with substances that render it unfit for human consumption. It might refer to an environment that contains elements that are breathable, but is subject to pressures that would instantly crush us. Or, like K218b, it might be a world with an ocean on the surface, but with potentially extremely heated depths. Consider the wider ramifications as you reflect on these discoveries. How many more planets are on the verge of becoming habitable balancing between being the cradle of life and a barren rock. In what ways does our Earth-centric definition of life restrict or broaden our comprehension of the universe? The James Webb Space Telescope is a shining example of human ingenuity and our bold endeavor to solve the universe's secrets in the history of cosmic exploration. Ultimately, the K218b discoveries are a testament to Webb's unmatched capabilities as well as the exoplanet itself. If you will, picture a detective with a magnifying glass so strong that it can pick up on the smallest hints that were previously unnoticeable to the human sight. For us, that's the James Webb Space Telescope, a cosmic investigator looking into the depths. Throughout its storied history, the Hubble telescope has altered our understanding of the cosmos, but Webb has come to further expand those possibilities. The wide wavelength range of Webb is a key component of its power. Think of the universe as a large symphony to understand the significance of this. Many of the distinctive notes that are released by various instruments, or in this case, celestial bodies, are inaudible to the average audience. But the Webb hears everything, even the longest hums and the smallest blips. Its capacity to notice everything has allowed it to obtain such precise information about K218b with only 2 sightings, something that would have taken the Hubble much longer to do. Furthermore, it can detect even the smallest whispers in the midst of the clamor because of its enhanced sensitivity, which is similar to a finely trained ear. These murmurs are priceless bits of information that, when combined, create the greater picture of celestial bodies such as K218b. Essentially, the Webb telescope does more than simply watch. It also hears, comprehends, and narrates stories about worlds that are far away from us. The Webb is still in the early phases of its cosmic journey, so anyone interested in space exploration, astronomy, or the vast tapestry of the cosmos should think about this. If 2 observations might completely change our perception of a far-off exoplanet, just think of the riches that await Webb as he explores the cosmic oceans further. Isn't it amazing to think that we're living at a time when we're actively involved in these cosmic discoveries rather than only watching them happen? What new boundaries shall we cross when Webb continues its journey? How will these discoveries alter the way we think about life, existence, and our role in the cosmos? We watch, we study, and we dream with bated breath. The persistent group of astronomers has solved some of the puzzles surrounding K218b, but they have much more work ahead of them. The MIRI spectrograph on board the James Webb Space Telescope will be their next traveling companion. The name may seem like a complex piece of jargon to those who are unfamiliar with it, but let's examine its meaning together. Think of the cosmos as a large stage on which all of the planets are performing. Spectrographs that analyze every detail of this performance, such as the MIRI, serve as our personal critics. They let scientists to identify certain substances in the atmospheres of far-off worlds by separating light into its distinct colors or wavelengths. It's similar to identifying distinct instruments in a symphony, each of which plays a different melody. There is a noticeable sense of excitement surrounding the use of MIRI. What mysteries will K218b reveal? Could it support or contradict the assertions of dimethyl sulfide, further confirming the existence of chemicals that indicate life? Or may it reveal whole new aspects of the exoplanet that have so far remained obscured? Imagine becoming a part of this big detective thriller for those of you at home who are enthralled with this celestial tale. With the aid of tools such as MIRI, every observation is a turning point, a hint, or a jigsaw piece. The globe waits anxiously as the squad starts this next stage. The wonder of it all is that you don't need to be an astronomer to appreciate it. We are all inherently involved in this cosmic story because of our curiosity and desire to learn. Our one and only goal is to find life outside of our terrestrial boundaries, amidst the cosmos' grandeur, tucked away between stars and the empty space. Exoplanets, worlds orbiting far-off stars, offer some of the most intriguing opportunities in this massive undertaking. Even if our missions to the moon, rovers on Mars, and probes flown to the furthest limits of the solar system have made enormous progress, K218b is but one chapter, an intriguing one that advances us closer to our end objective. You see, discovering water or specific chemicals in an exoplanet's atmosphere is like discovering a piece of a huge cosmic puzzle. However, discovering life is like witnessing the entire picture come to life, narrating a tale that has the capacity to alter humanity's position within the vast scheme of the universe. Take a moment to consider the significant ramifications of such a finding. What impact would it have on how we view life, its brittleness, and its pervasiveness? Knowing that the spark of life isn't exclusive to our pale blue dot, how would society react? How would faiths change? And how would philosophies develop? It represents a paradigm shift, a new dawn in our understanding of the cosmos, and a game changer. Now recreate the feeling of awe you get when gazing up at a starry sky. Every glimmer of light may be a universe unto itself. It is both exciting and humbling to consider that one or more of these far-off worlds may be brimming with life, whether it be complex beings or simple microorganisms. It draws us into a universal story of life, in which Earth is but one of innumerable worlds on which life has successfully established itself. However, there are several difficulties along the way. As we all know, space is vast and enigmatic. The circumstances are harsh, the distances are vast, and the variables are innumerable. But with each action we take, each observation we make, and each particle we find, we get closer to the answer to one of the most profound and ancient questions. Are we alone? Therefore, keep in mind that we are on the verge of making a discovery that might completely alter the course of the universe as scientists continue to delve deeper into space and as telescopes like Webb break through the veils of far-off worlds. The tremendous diversity and individuality of the world strewn throughout our galaxy is a revelation that highlights the connectivity of all life and the awe-inspiring nature of life. You would expect that samples of every type of celestial objects would be found inside the boundaries of our own solar system. However, the cosmos never fails to amaze us in its own unique way. Sub-Neptunes like K218b are a mystery. There is nothing like them in our own cosmic backyard, neither as gaseous as our Neptune nor as stony as our Earth. In essence, these planets are neither here nor there. They are the middle children of the cosmic family. The interesting part, though, is that although our solar system appears to have escaped this group, the larger galaxy is brimming with them. Therefore, we live in a cosmos where the absence of certain things in our immediate environment is the norm on a global level. Envision traversing an expansive woodland where, as far as you are aware, each tree is either an oak or a pine. You then find yourself in a forest one day where all the trees are of a kind you have never seen before. Astrophysicists get revelations like that from Sub-Neptunes. Furthermore, we are now discovering that the blueprint of our solar system is only one design in a vast collection of celestial architecture. Contrary to what we originally thought was a conventional template, there are so many intriguing questions raised by this. Why does our system lack such planets? What special circumstances exist elsewhere in the galaxy that lead to their formation? Importantly, what does their abundance indicate about the possibility of life? Shouldn't we concentrate our search for extraterrestrial life on these planets as they are the most prevalent kind? However, we're not merely charting unexplored territory as we delve farther into the cosmos, discovering sub-Neptunes and worlds that are different from our own. In reality, we're mapping out the fundamental characteristics of life's possibilities outside of our pale blue dot. The deep questions these heavenly discoveries invite us to consider are just as fascinating as the worlds themselves. Is there a higher probability of life elsewhere if such planets are so common? Could it be that these middle offspring of the cosmic family are brimming with living forms, possibly even civilizations, that we have yet to comprehend, given how frequent they are? Take a moment to consider the astonishing ramifications. Our earthly viewpoint has frequently depicted a sense of isolation, with our planet appearing to be the only one capable of supporting life. However, the cosmos may be sending us a different story, one of potential and plenty. What if there are worlds strewn throughout the universe where life has established itself in ways we could never have predicted? Sub-Neptunes with distinct ecosystems, gaseous planets with floating life forms, or oceanic worlds with submerged civilizations. This more expansive viewpoint both delights and humbles. It informs us that we are only a single act in an unending cosmic adventure epic. Our successes, setbacks, aspirations, and desires are all a part of a larger story that extends over millennia and galaxies. The universe is intimate despite its grandeur. As we explore its mysteries further, we are essentially gazing into a mirror and considering our own lives. Is the universe a colorful tapestry of life, with threads woven in intricate and exquisite designs? Or are we alone? These issues touch on philosophy, spirituality, and the core of what it means to be human in addition to science. We are on the verge of a better knowledge of who we are and where we fit in the universe, as well as fresh discoveries. We're assembling the jigsaw of life in the infinite fabric of the universe with every planet we find, every speck of water, or every trace of gas. Our personal search for knowledge and connection is reflected in every discovery we make. Planets like K218b serve as powerful reminders that we have only just begun to explore the universe. Let's keep sharing, learning, and marveling as we go through the universe's secrets together. For more in-depth explorations of the unknown, please like and subscribe to this video if you have been enthralled by this cosmic trip. Do you want to go on another trip? After you click on the video that appears on your screen, let's go on another exciting adventure. Don't forget to share your opinions with our community by leaving a comment. Your thoughts are as broad as the universe itself.